Hello, can you guys hear me now? Hear me now? Cool. Yeah, if you comment your names, I will do the register in a sec. I'm just trying to work out where we actually got to last lecture. Um, I don't think we finished the past paper, but I could be incorrect. Ah, here we go. Cool. Did we do this question, or is this just where we stopped? If you guys comment while I do the register, that would be great. Pretty sure we did it. Okay, cool. So we're on the next one, bro. Thank you, Grace and Jasmine. All right, so we have got Ed, we've got Dan, Harry for later. That's fine. How's it, Melissa? Don't know. Ed could be a while. Jack, Molly, Jake, Jasmine, Rob, Jolie, Ed. Oh, Ed already did Ed. Grace, Emerald, Ollie. Cool. So missing Elizabeth, Poppy, and Dom. If you guys are there, can you? Yeah, I got your name down. Don't worry. Dom, Poppy, and Elizabeth. If you guys are here, please let me know. Right. So starting with this next one then. Okay, what question did we get to? Dom is here. Okay, cool. Um, 6, 7. So we're on question 8 by the looks of it. And I think it's this one. Yep. All right, so we got a modeling question, trigonometry based modeling. 5 marks, so I'll give you guys 5 minutes to try this one. Yeah, and then we'll go through it. Sally's watching, can't comment. Cool. I can see your comments now, Dom. All right, it's 5 minutes on the clock starting from now. No worries, Elizabeth. I've ticked you off now. Cool. Present. Cool. All right. So depth of a boat in a harbour. Okay, boat enters the harbour at 6:30. It's 2 hours to unload its cargo. The boat requires a depth to be that. Find the depth of the water when the boat enters the harbour. Okay, so we need to put in 6:30, and it's hours after midnight, so we need to put in 6.5. So D equals 5 plus 2 lots of sine 30 times, so what's 6.5? Yep. So 5 plus 2 sine 30 times 6.5. I feel this needs to be radians, but we'll see. Depth of water comes out as 5.4. Sounds about right. 5.44 meters. If we did it in degrees, we would get, oh, it's still, very interesting. Damn, what's it going to be? Yeah, I think this probably should be in degrees, you know. It's more a gut feeling because got sine of 30 times t, and 30 radians is huge. So yeah, I think it's going to be degrees for this one. So 4.48 meters for this one. Okay, find time to the nearest minute when the earliest time the boat can leave the harbour. And it says here we can't just use a graphical calculator, so we need to solve it. So the depth needs to be at least 3.8 meters. Cool. T is time after midnight. Okay, so we're going to put 3.8 equals 5 plus 2 sine 30t. Going to solve this to find t, and then try and translate that to a time after midnight. So if we take away 5 from each side, going to get minus 1.2. Here's 2 sine 30t. Divide that by 2, minus 0.6 is sine 30t. Now I need to stretch my limits, so I'm going to times them by 30. So we're going to go from 30 to t to 720. Let's get rid of all this stuff now. We want the earliest time, so we want the smallest solution to this. So we're going to solve for 30t. So 30t would be sine to the minus 1 arc sine of minus 0.6, which gives me minus 36.9. Okay, if I divide that by 30, the times can be negative, so that's not going to work. So we need to plot a graph and work out what the next few times are to work it out. So we've got a sine curve. And we need to go between 30 and 270. So I'm going to draw a few of these. Okay, and our first value that we got was minus 39 degrees. 36.9, sorry there. So we can look here and here and find these two values. So this value, if 36.9 is measured from 0, this value is going to be 36.9 measured from 180. So if we do 180 plus 36.9, that gives us 216.9 as our value there. Okay, so that might be it, to be honest. So if we call that 30t, if I divide that by 30, we get t is 7.23. Oops. So let's just read back to the question. T is number of hours. Oh dear, number of hours after midnight. So that would be 7 a.m. Our boat only arrived at 6:30 a.m. and it took 2 hours to load the cargo. So the boat's still there at that time, so that's no good. So we're going to need to find the next one as well. So the next one is going to be 360 take 36.9, which is 323.1. So let's try that one. If we divide that by 30, we get 10.77. That sounds a lot better. So just going to make some space so we can see the actual question again. So that gives me 30t is 323.1. So t is 10.77. We want the time to the nearest minute. So that's 10 hours. So 10 a.m. and 0.77 of an hour. So 0.77 times 60 is 46.2. So 10:46 a.m. Are we still there? So 6:30. It takes 2 hours to unload the cargo. So that'll make it 8:30. So yep, 10:46 a.m. is going to be correct. Cool. Anyone got any questions about that? All right. Next question then. Oh yeah, this one looks great, doesn't it? Cool. So we got a parametric question, 10 marks. See how you guys do. Take time with this one because it does look quite difficult. Cool. Not seeing any comments today, guys. Please, can you make sure you're giving these a go as well? So we want to differentiate this. So it's going to be implicit differentiation. So x squared is going to differentiate to give us 2x. Then we've got to use product rule on these. We're going to get the 2x will differentiate to give us 2. The y will stay the same. And the y will differentiate to give us dy dx. So we get 2x dy dx plus 6y dy dx equals 0. So factorize out dy dx and rearrange. So if I put everything on the other side, so it's that. Factorize out, so dy dx minus 2x plus 6y. Bring it all over to get dy dx 2y, take 2x over minus 2x plus 6y. Then we just need to divide it all by 2 to get what they've got and rearrange it slightly. So divide all that by 2 and you will get what we're after. Okay, so that's the first part. The next part. Points P and Q represent the points furthest west and furthest east. Using part A, find the coordinates of point P. Okay, so these are the points where the gradient, if you look, is infinite. The gradient's an asymptote. And to find an infinity, we can divide by 0. So we can say 3y minus x equals 0. So we know 3y equals x. Now what we can do is we can put that equation into this equation and solve it for x and then solve it for y. So I think let's solve it for y first. So we'll put it in as x. So we'll say 3y all squared minus 2 3y times y plus 3y squared is 50. So we get 9y squared minus 6y squared plus 3y squared is 50. 9 takes 6 is 3. 3 plus 3 is 6. So we get 6y squared is 50. Let's go check this through. Yep. So y squared is 50 over 6. So y is going to be plus or minus root 50 over 6. Root 50 over root 6 even. Which simplifies to plus or minus 5 root 3 over 3. Okay, and to find x, all I need to do is rearrange that equation we found just now, the red one. So if I rearrange that, we get y, we get x is 3y, so x is going to be plus or minus 5 root 3 because we times y by 3. Cool. Okay, explain briefly how to find the coordinates of the point that's furthest north of the origin. So to find that point there, wait, is that what we're doing? The point that is the furthest north of the origin. That would be our maximum point, and we would set dy by dx equal to 0. And solve for x, sub into the original function. So solve that one, put it into that one. So basically we'd say y equals x and solve that instead. Okay. We're doing pretty well for time today, guys. I'm racing through it. So, but I would like to see some more comments. Might start choosing people to give me some replies. Okay, another trigonometrical, and an exponential modeling question. So it says it's worth 8 marks. So I'm going to give you guys 10 minutes, and I would like Rob, Emerald, Jake, and Jolie to give me some kind of a response for this one. Cool. So 10. Yeah, comment anything, Ollie. If you are finding it difficult, comment for hints or anything else. Okay then. So yeah, Emerald sent me some methods, so if the rest of you could join in as well, that'd be good. But thank you, Emerald, that was awesome. Okay, so yeah, let's do this. So it looks like a quotient rule, but it's not because 40 isn't a function. So this is just a standard derivative or standard integral. So we want to separate our variables, integrate each side, and find h. Going to check Emerald's working as well. Yep, awesome. So if we split this up, we're going to get 1 over h. We can put the 40 anywhere we like. We could bring it up here, leave it on the other side. Let's leave it on the other side. Equals cos 0.25t over 40. And then dh is going to be here, and dt is going to be here. So 1 over h is going to integrate to ln h. Cos integrates back up to sine, and we're going to get 1 over 0.25. So that's 1 over quarter, which is 4. So we're going to end up with 1 over 10 sine 0.25t, I think. Yes, Emerald, you had the right idea, but you didn't bring the inside out as a fraction like you need to do. So remember, with reverse chain rule, we've got to pull out the inside of that. So you get 1 over 10 sine 0.25t, and we need a plus c there as well. Yep. Okay. So we need to put given the passenger starts off 5 meters above the ground, so we know ln 5 sine of 0 is 0, so ln 5 equals c. So I can rewrite the whole thing as ln h is 1 over 10 sine. I'm going to call it t over 4 just to save some space now. Plus ln 5. Oh, I just did all that with my Mac. Could you guys hear that right? If you couldn't, I can talk through it again. So we separated the variables, integrate both sides, blah blah blah, got ln this plus 1 over 10. I was saying Emerald problem with your workings was that you forgot to bring the 0.25 outside, so we need to do 1 over 0.25, which is the same as 1 over a quarter, which is the same as 4. So we get 4 over 40, which is 1 over 10. Cool, so then I put plus c, I put in that the height was 5 when c was 0. Use that to find plus c, and now I'm going to rearrange to get h. So we will combine the two lns, so we'll do ln h minus ln 5 is sine 0.25t over 10. So we get ln h over 5 is 0.1 sine 0.25t, and then we can e both sides to get h over 5 is e to the 0.1 sine 0.25t, and then times by 5 to give the show that. Cool. So that's the first bit, which is probably the worst bit. State the maximum height of the passenger above the ground. So the max height is going to be when this is 0. So we're going to solve that for 0. So we get cos 0.25t is 0. Cos is 0 when the angle is 90. So if we put 90 in as our... This is probably in radians, isn't it? Yeah. Okay, put the calculator in radians. We want to find the maximum height. Actually, we can probably just do this. There's a couple ways we could do this actually. It's going to be the maximum of the exponential graph there. So let's think. The biggest that sine can be is 1. Yeah, so the maximum of that bit there is 1. E to the 0.1 times 1 is going to be 0.1. So 5e to the 0.1 give me 5.25. Or 5.26. So I think that's what we're going to be looking at. We can double check it though by finding the maximum point of our curve here. So if I set that equal to 0, h, we get the maximum would be when cos 0.25 is 0. If we solve that, cos is 0, like I said just now, at pi by 4. So we can say 0.25t is pi by 4. So our maximum time would be pi by 4 times 0.2 divided by 0.25, which I think would just be pi. Pi divided by 4. Yep, just gives us pi. So when t is pi, we have a maximum. And if I put t as pi, well, if I think about sine, t as pi is going to be 0 there. So we get e to the power 0. Yeah, so my maximum is 5.26. Because that gives me a lesser value than what we had just now. Cool. All right, last bit. Passenger reaches the max height for the second time t seconds after the start. Find the value of t. Okay. So we want to find when sine is a max for the second time. So we already had this one. The second time is going to be this one. And that angle there would be... I used the wrong thing just now, didn't I? Damn it. Should have been pi by 2, not pi by 4 in the last bit of the thing that I did. Oh well. It doesn't matter now. So sine is the maximum at... that would be 2 pi plus pi by 2, which would be 5 over 2 pi. So the value t will be when the angle 0.25t equals 5 over 2 pi. So 5 over 2 pi divided by 0.25 gives us a t value of 31.42. Cool. Anyone got any questions about this? Yeah, Emerald, nice. Good work. All that you got wrong was that first bit. Cool. Right, let's try another one. So right, we've got a binomial question. It's a 10 mark 10 mark binomial question. See how you get on. This should be pretty straightforward. Cool. All right, let's see how this goes. So, using binomial expansions to show this one. Okay. All right. So for part one, we need to write these both out as separate powers. So we're going to get 1 plus 4x to the power half times by 1 minus x to the power minus a half. And we need to expand both of these up to the x squared term. So we're going to get, yep, both of these are ready to go. So we get 1 plus a half 4x plus a half minus a half 4x all squared over 2. So that's our first one. Second one is going to be 1 minus x. Well, let's do that a bit better. 1 plus minus a half times minus x plus minus a half minus 3 over 2 minus x squared over 2. So those are my two bits. All I need to do is expand those and times them together. So for the red one, we get 1 plus x over 2. And then we're going to get 0.5 times 1.5. We're going to get, was it 3 over 8? 3 over 8 x squared for the first one. Second one is going to be 1 plus 2x and minus 2x squared. I think that's right. I think it's a negative there. Positive, yeah, negative. Yeah, cool. So we get those two brackets. So we need to expand those two brackets. And we're only going to bother expanding up to the squared term. So 1 times 1 is 1. 1 times 2x is 2x. 1 times, so I've done that one. I've done that one. I'm now going to do this one. So 1 times x over 2 is x over 2. Now let's do this one, plus 3 over 8 x squared. Let's do that one, minus 2x squared. And then we're going to times the two x's together, plus x squared. Cool. Nothing else will work. Anything else you do will give you an x cubed term or an x to the 4 term. So this becomes 1. So we got 2 plus x over 2 is plus 5 over 2x. And we got 3 over 2, take 2, plus 1 is 3 over 2, take 3 over 8, take away 1, which is minus 5 over 8 x squared. So that is how you do it. Whoa. Okay, part 2. Why should the student not use x equals a half? Well, our expansion was valid for Our expansion was valid for 4x less than 1, so therefore it's only valid for x is less than a quarter. So not valid. It's only valid for those. Okay, last bit. Substitutes 1 over 11 into approximate root 6. Cool. These are always fun. So I'm going to scroll this up a little bit, get some more room. Okay, so we're going to start off by substituting 1 over 11 into the left-hand side. So we get 1 plus 4 over 11 over 1 minus 1 over 11, all square rooted. So I'm going to try and simplify this. So we'll get 15 over 11 divided by 10 over 11. Which gives me 3 over 2. So we've got square root of 3 over 2. Okay, we need to get a root 6 out of this. So what do I need to times that by to get root 6? Well, we got 3, so if we can somehow times that 3 by a 2, we'll get 6, but we still got the 2 on the bottom. So if I split this up into root 3 over root 2, things might be a little bit easier to make some sense of. So root 3 over root 2. Okay, so and that's going to equal at the moment. At the moment, we haven't changed anything. So we can just say root 3 over to root 2 equals my expansion when I put in 1 over 11. So we get to that. Problem is, that's not really an expansion to root 6. At the moment, it's an expansion to root 3 over root 2. So if I times the right-hand side by root 2, it will now become an expansion of root 3. So we can say root 3 is root 2 times all that. But I want root 6. How can I turn root 3 into root 6? Well, I can times it by root 2 again. So root 6 will be root 2 times root 2 times all this stuff. Root 2 times root 2 is just 2. So if I expand it one last time up here in green, we're going to get root 6 equals 2 lots, or equals 2 plus 5 times 1 over 11 minus 5 over 4 times 1 over 11 squares. So I've times that all by 2. And we can chuck that. Oh, we want a fraction in simplest form. Okay, keep going with it then. So root 6 equals 2 plus 5 elevenths minus, here we go, 5 over 121 times 4, 484. Cool. Right, that's not ideal, so we're going to need... Okay, no, it's not too bad, because 484 is 44 times 11. So if I times the middle fraction by 44 on top and bottom, we get 220 over 484 minus 5 over 484. 2, well 2 is going to be 484 times 2, so that'll be 968 over 484. Type all that in, 968 plus 220, take 5 is 1183 over 484. I don't know if this is going to simplify. No, it does not simplify that, is it? Cool. All right. Okay, maybe have time for one more today. We can do it. We can start it, but I doubt we'll finish going through it today. That's fine. So we got 10 minutes on this one. I think we might have done this one before. We've done one very similar to it. There was one similar to this in the mock. So 10 minutes starting from now. Cool. All right, so we've got 5 minutes, guys. Let's try and get through the first bit at least. So given the car's value was 32 on the 1st of January and 50,000 on the 2012. Okay, so it's first valued on 2001. So T is years after it was first valued. So 2002 would be 1 year after. Let's write a table first. So 2002 would be 1 year after. 2005 be 4 years after. 2012 would be 11 years after. So 32,000 equals a p to the power 4, and 50,000 equals a p to the power 11. If we divide those, we can find out what p is. So 50,000 divided by 32,000 is going to be 25 over 16. The a's will cancel. P to the 11 divided by p to the 4 will be p to the power 7. So we can do the 7th root of 25 over 16, and we get p equals 1.0658 to 4 decimal places. Okay, and then to find a, we can just put that back into either of the two equations. So we know p is 1.0 whatever. So if we divide 32,000 by 1.0658 to the power 4, we get a is 24,799.7, which is approximately 24,800. Okay, yeah, we won't get this done. We'll leave it there, I reckon. I'll put a line there and put group F next to it, and we'll finish this on Tuesday. Cool. All right, thanks, guys. Get the assignments done. Make sure you're still revising for things, and have a nice weekend. I'll see you on Thursday. Cheers, guys. Bye.